I don't think anyone in the world would dispute the fact that there are three words you never want to hear, and that is, you have cancer. But what science is doing now in current times is turning that fear that when you hear those words we're turning that fear into hope. And the hope is based on the realization that actually, while new drugs are on the market the whole time, what we actually really know is that the immune system, the natural immune system that we get through evolution, is actually designed probably optimally to get rid of cancer as well as infections. Now, while that is great, what's even better is that scientists have discovered how to genetically engineer the immune system. So from an evolution, we have an antibody that gets rid of an infection, and we have a killer cell which kills an infected cell. So we can combine these two technologies. So we now have a killer cell which is engineered to have a GPS tracking system that can carry that T cell, that killer cell, through the body to actually locate a cancer cell and kill it. And that's called CAR T cell, or chimeric antigen receptor T cell therapies. So it's this new age of immunotherapy. Now, if you know that, it's a very expensive process at the moment. It costs about $500,000 per patient. But if you know that this is possible, what we can then do is start to make these killer cells from stem cells. Is compromised because they have cancer, they've had chemotherapy, and they're probably aged. So they have a pretty lousy immune system. If you could create a new immune system from stem cells, you can get a very healthy repertoire of these cancer-killing cells, which when fed back into the patient will give a much stronger and cheaper and quicker response to the cancer. Now it's bad news to know that you have cancer, but it's fantastic news to know that there's these new therapies on the horizon. So the next extension to that thinking is to say, well, if we're smart enough, why don't we engineer a normal patient's immune system before they get cancer, and as a sort of prepare the immune system before the attack of cancer comes. I think that's where Brian will tell us about the value of looking at the normal, healthy person and how we can engineer those cells to attack cancer.
Yeah, so one of the issues that arises when an individual has been diagnosed with having cancer is the current status of their immune system. And oftentimes, the first line of treatment that's offered to them really hammers their immune system. So what happens is that when they then become patients that can enter into a clinical trial for the procedures that Richard's talking about, using the CAR T cells, the modified immune cells, their own immune system is really not in good shape. It has been subjected to chemotherapeutic drugs, it's been subjected to potentially radiation, and all of these modalities really deplete their immune system. So it's asking a lot to really be able to reactivate that immune system using immunotherapies. So it would be much better if we could have knew the status of our immune system before we were diagnosed with any particular disease, for that matter. So if we can arrive at a situation where we know what our immune status is like, potentially bank our immune cells, perhaps expand those immune cells, store them away ready for any disease that might arise in the years to come. Then that would be a terrific thing to be able to be presented with if you're told that you have cancer. Well, you could say, well, that's not a good situation. I'm sorry to learn that, but I have banked my immune cells 20 years ago, and these immune cells are primed and they're ready to be used for the strategies like chimeric antigen T cell receptor strategies to target and fight this cancer. So I think that we're really at we know a lot more about the immune system now than we've known for many years. We know how it fights cancer, and we're now in a situation where we're able to take that immune system and manipulate it in such a way that it can target cancer much better than under normal circumstances.
Yeah, I think the other very important point to note is when we have these cancer-specific T cells, these CAR T cells, which are brilliant technology, they are targeting a cancer-specific molecule. But if that cancer mutates and loses that molecule, these cells become blind. So sometimes it's better to target not one but multiple markers. The other very important thing to remember with cancer patients is that because their immune system is depressed, they can die of infection. And an infection can be a killer of up to 50% of cancer patients. So the model that Brian's talking about of taking a healthy immune system and activating it broad-based will give the patient not only the ability to kill the cancer, but to defend themselves against infection. And that becomes very important because you can imagine the CAR T, the killer T cell, is a little bit like the needle bursting the balloon. It pops the balloon and the balloon fragments. That cancer fragments and gets into the bloodstream. It can then be subject to activating the patient's own immune system to give you more defense against the cancer. So there are different layers of how we can use the immune system to defend against cancer. The cancer-specific attack, but to broad-based immunity, almost like a vaccine against other cancer molecules, and then secondary against potential infections. And I think that's one of the most important things we can think about with this new immune health centre that we're building here. Is that we will have the people's cells frozen away when they are healthy, and as the technologies that have been developed in our laboratories, we can apply them to improving those patients' cells before they get sick, before they get the diseases.
Excellent. I think it's brilliant.